All right, so this next type of problem is an efficiency problem. Now, in order to do this sort of problem, you need to really understand the power problems. So make sure that you are okay with that stuff and then continue watching. All right, let's take this lamp. So this lamp is plugged into the wall and it is taking in energy. Okay, we're going to label that as E with a little subscript in, input energy. Okay, so that's all the energy that's going into the lamp. Now, the lamp is producing light, right? That's the light that it's producing is the purpose that we're turning the lamp on. We call that the useful energy output. Okay, I will label that over here as E out. Okay, I need to distinguish to you guys that that's the useful energy output. That is the energy output which is actually the purpose of the lamp being turned on, but there is waste energy in there as well. So along with the light that the lamp produces, the lamp also produces a fair amount of heat. Okay. Now the heat is waste energy. We do not want that heat energy to be wasted. We don't turn on our lamp to heat our room. That's not the point of it. So the energy that is going towards the light is the useful energy output that we're talking about. Now if E in and E out equaled each other, we'd have 100% efficiency, which just doesn't happen in the real world. There's always energy that is lost in some way, and usually in the form of heat. So no real device is a perfectly efficient energy converter. Some input energy is always going to be converted into waste energy, usually in the form of heat. So we can calculate the actual efficiency of devices. That can kind of help us determine which ones are doing their job well. And we have a formula for that. So that's what we're going to be calculating in this video. So efficiency, which I often just use EFF to symbolize, okay? It is the useful energy output divided by total energy input. And then that's times 100%. Okay, so we can do kind of a short form of that. Efficiency equals E out divided by E in times 100. So the E out is the useful energy out that we're talking about. So it's the energy that's actually going towards the device performing the task that we want it to perform. So the really easy efficiency problems, we'll just give you the E in and the E out and ask you to just solve for the efficiency. So that's nice and easy, but it is not nearly as fun as the more complicated ones, such as the one that we're going to do here. So in this problem, there is some more confusing information. What you have to do is you have to calculate the E in and then calculate the efficiency from there. So it's a two-part problem, a little bit more challenging. So the first step when you see an efficiency problem is to figure out kind of what values are affiliated with E in and what values are affiliated with E out. Remember that E out is going to be the energy that is actually being used to perform the device's purpose. So keywords to look for would be something like it produces energy, okay, which is something that we see in this problem. So what I am going to do first is make two headings just to help me organize my information. Okay, so right here I see a 60-watt bulb produces 10,000 joules of energy in 10 minutes. What is its efficiency? So produces is our keyword. The 10,000 joules is going to be our E out. Okay, so now we have a power value and a time value. Those values are going to give us kind of the amount of electrical energy that's actually being taken in by this bulb. Okay, so those values are going to go over here underneath the E in. P equals 60 watts. Time equals 10 minutes. So as you guys remember from your power calculations, we need to make sure that time is always in seconds. So to get 10 minutes into seconds, I'm going to multiply that by 60. And I'm going to get time is actually 600 seconds. Okay. So my first step here is to actually calculate E in. So I am going to use the formula that we used in our power calculations, where E equals P times T. So P times T is 60 watts times 600 seconds. And that is 36,000 joules. Okay, so our E in is 36,000 joules. Our E out is 10,000 joules. Okay, this is the first step of the problem. Now we have to do the second step, which is actually solving for efficiency. I'm going to do that in a different color here. So again, as always, we always need to use our formulas. We always need to write our formulas down. Sorry. So efficiency equals E out divided by E in times 100%. Okay. This is our E out value. That's going to go there. And this guy is going to go there. Okay. So our efficiency is 10,000 joules divided by 36,000 joules times 100%. So when we complete that calculation, we will see that the efficiency is 28%. Efficiency is always expressed in a percentage. That is the unit for efficiency. One really good way to check whether you are correct for an efficiency problem is that your percentage is under 100%. We can't have over 100% efficiency, so if you've calculated it and it comes out over 100%, you've obviously done something wrong. So that's your indicator that you need to go back and check. More often than not, you've just switched the E out and the E in values, and you have the wrong calculation there. If you need more practice problems, there are more online on the blog, colganscience9.edublogs.org. Happy physicsing!